Hi everyone, I'm Rishika. This is my assignment 1. This is data exploration and manipulation where I'll be reading CSV file, describing the data and finding if there are any missing values. I then identify independent and dependent variables and then I plot for these variables I've selected. So for the read CSV, I gather information presented by using data head. Dealing with data, I basically describe it. Missing values to prevent data corruption or failure to record data, especially because my CSV file has over 1,000 data, which is susceptible to being affected by any missing values there. So variables is identifying independent and dependent variables and plotting box plot for the variables itself. In terms of mixing values, I used the is now method and it indicates 0, which means there are no missing values present to affect the data. I imported certain application. Okay, then I have PD and PSNS PLT, and then came in standard scalar, and then I read the CSV file, and then I used that dot head. Okay, so like thinking that dot head is this. I attain all the information available in the CSV file in a summarized manner, up to only four rows. Okay, next is variables. As shown on my right side, I selected credit amount and age in years. So on my left side is my explanation. I selected age and credit amount because in real life situation, elderly might retire and teens might be still undergoing education, but there might be some elderly and teens who might be taking on part-time job for income that can actually affect the credit amount. I use it by plotting the box plot. So my analysis is y-axis is credit amount and x-axis is age in years. After the age of 60, there are no outliers. There's also a sudden increase in max credit amount from age 61 and 62 to age 63. Then there's a sudden decrease in max credit amount from age 63 to 64. Age 41, as shown here, has the most credit amount, and age 31 has the most significant outliers. There is also no credit amount applicable to age 70. Clustering. So building k-means clustering process. Okay, this is the process. Scaling and standardization is used because it's performed normally to prevent features with wider ranges from dominating the distance metric, especially because my CSV, as I mentioned earlier, has over 1,000 data. Fitting the model to data set, creating models that can summarize data using a small set of numbers, okay, helps to provide a very brief, small description of the data itself. Identifying centroids, which has two parts. The first part is n clusters, which is number of clusters. Then there's n init and max iter. Max iter is the maximum number of iteration of k-means algorithm for a single run. Identify centroids. Okay, they are identifiable to split the data, okay, into many groups by identifying a similarity. And then there's these leaders, which is known as centroids, which indicates the average location of the group. SSE. Okay, so SSE is basically k-means dot inertia is like, okay, instead of writing the whole mathematical formula, we just made it into a small code. This is used to evaluating model. I imported these applications and then I use df equals to date ilog to identify the columns which I'm using as my variables. Scatter plot 01. Okay. So as shown here, there are three centroids, and then centroid 1 is strong positive linear, centroid 2 is null or no relationship, and centroid 3 has gaps in values. So gaps in values occur when there is extreme values, okay, and in these extreme values there might be very huge gaps. So that's why it scatters a lot as shown here. Elbow method 01 is the optimal number of clusters, okay, and which can be identified by inclination spot, okay, and in this case it's 6. I use WCSS instead of SSE, which is almost the same thing. Scatter plot. Centroid is used in optimal number of clusters, which previously have been mentioned. Centroid 3 and 2, okay, is null or no relationship. Centroid 1, 4, 5, and 6 has gaps in values, with centroid 5 having the most gaps, indicating that it has the most extreme values in terms of like extreme value differences. 3D. Okay, this is my 3D. The scatter plot is cramped due to several data being present. The installment rate is affected by the amount. Scatter plot 2 is neatly organized in a vertical manner for centroid 1 and 3. Okay, so I use credit amount and duration of the installment. Why did I select this is because I feel that in certain scenarios where higher credit amount might make faster payment as opposed to those who struggle with obtaining a decent credit amount. Now, elbow method 2. Okay, my identification of inclination spot is 6. Okay, and yes, as you can see, the data is very neatly arranged again, with the centroid 3 having the least amount of gaps, and the higher it goes, I'll notice that the more scattered it's becoming, especially centroid 6, centroid 6, because possibly because it has gaps due to extreme value differences, as I mentioned earlier. Then there is 3D scatter plot, which is also cramped, and the present resident, which I call it precedence, is affected by the amount, the credit amount. There is hierarchical clustering, where I imported this. Okay. Then there's box plot. This is before scaling and after scaling. So scaling actually helps to make attributes more comparable. As you notice here, my y-axis and x-axis is reduced, okay, to make the comparison more visible for me. Now, process to build a dendrogram. I use distance matrix where the data format when performing hierarchical clustering. Then there is identify lowest dissimilarity clusters. I find and merge these clusters. In this case, I use the default version word, okay, shown here. So the default version word actually picks clusters such that the variance within all the clusters increases the least. This is my dendrogram. There are 3 clusters differentiated by the colors. Then this is the process to build the algorithm clustering model. Okay, so I set the cluster value as 3, and I fit the model and predict clusters. Okay, so yes. Next, this is what I have obtained. Okay, with green being widely scattered, while purple being the least scattered. And as you can see for the red here, it's from cramped to more scattering as well. It's more of positive linear. Okay, process to build the model using silhouette score. So I first calculate the silhouette score using this code. Then I evaluate it. So evaluating silhouette scores is done for different n clusters. And in default, I use 2 to 11 range. Dendrogram. This is my dendrogram where I use the highest silhouette score based on the graph, okay, to identify my n clusters, which in this case is 3. Algorithm clustering model. Okay, this is what I have retrieved. 3 has the least, while purple has the most. The preferred model in the end is hierarchical clustering. It actually distinguishes based on prior beliefs. The results of k-means is unstructured, but that of hierarchical is more interpretable and informative. It is easier to determine the number of clusters by hierarchical clustering dendrogram as compared to other model I've seen. And yes, there might be large data set, but we have used distance metrics to mitigate it. Thank you.